Hi students, the subject name is EE8010 Power System Transients. Today we will learn the basic concept of RL sine wave excitation circuit. Before that we will discuss the basic concept of transient. First we will discuss what is meant by transient. Transient is nothing but if any one of the fault occur in any particular system, that means any particular circuit, if a sudden changes in the circuit, the conditions such as when a switch or closing or fault occur on a system, the transient period is very short duration. This is the main thing. Next, the effect of transients on power system. The main effect is the electronic components accuracy will be less, and next one is the efficiency of that system. That means if efficiency of the motor or efficiency of the equipments or components is very less. When the transients will occur, the efficiency of the system is very poor. The next one is if any transient occur on motors, it easily get heated up, so which leads to insulation also fail. The next thing is IC may be burnt. The final one is it is too difficult to detect the fault. If any one of the transient is occur on that particular system is very severe, mean to detect the fault is difficult too difficult. And next one is this is a life of the device, the life of the whole system is short. Next we will discuss what are the factors to be considered to categorize the transient. First one is peak value of the transient, that means is the crest value is the maximum value of the waveform of the transient. Next one is area of the transient, and next maximum rate of rise of transient, that means is a triple RV. And next one is duration of transient, and final one is frequency of the transient. These are the basic factors we have to consider the transients. And next one is importance of study of planning. First we built a power station. First we have considered the transient problems. In this system in which the aim is in the decide on new as well as upgrading the existing system elements in a system to adequately satisfy the loads for a free seen future and to work properly in any adverse condition. And that means the study of switching transients in integrated system is especially related to EHV sites. This is the main consideration of EHV fields. The possible elements in a systems are generation of facilities, substations, transmission lines and cables, capacitors and reactors. These are the importance of study of planning in transients. Okay, next one is current shopping. This is the main thing of power system transients. In this current shopping is the production of a high voltage transients occur across the contacts. That means occur across the circuit breaker air blast circuit breaker contacts. When the breaking the low currents, that means in this circuit, that means the unloaded transformer or reactor magnetizing current, the powerful deionizing effect of circuit breaker contacts, it means the air blast causes the current is zero well before the natural current zero is reached. This phenomena is called as current chopping. This phenomenon is also interruption of the current before its natural zero. This is the main thing of current chopping. Okay, next we will discuss the basic circuits of RL sine wave excitation circuit. And this is a circuit of sine wave excitation. In this circuit we have considered R and L is connected as a series. R is nothing but resistance of the circuit, L is nothing but inductance, V is source side voltage, S is nothing but switch is act as a circuit breaker. In this switch, that means the circuit breaker will be closed. That means the flow of current in the circuit is RL. That means RL means RL circuit. That means we have applying KVL, Ri plus L into di by dt is equal to V. V is nothing but is a sine wave, is a particular frequency. Omega is nothing but is a frequency, supply frequency. So V is rewritten as Vm into sine of omega t plus theta. In this equation, sine of omega t plus theta, you have considered sine a plus b formula. So we have to expand sine a plus b is equal to sine a cos, and at that formula, sine a plus b is equal to sine a cos b plus cos a sine b. Next, we have considered the power factor. Power factor is equal to cos phi. Cos phi is equal to r divided by modulus of z. Z is nothing but impedance, is a source side impedance. We have rewritten as z is equal to square root of r square plus omega square L square. We have assumed the source side impedance is, we have a very negligible value compared to the load side. So V is nothing but source voltage. When the switch S is closed, the equation can be rewritten as Ri plus L into di by dt is equal to Vm into sine of omega t cos theta plus cos of omega t into sine theta. Already I told the equation 3.2.2 can be rewritten as in that equation. So we have taking the Laplace transform on both sides with respect to omega. So the equation we get r into I of s plus L into s into I of s minus L of I of 0. In this term, L of I of 0 is nothing but is a initial current is equal to Vm into cos theta is a constant term. Sin omega t, we have take a Laplace transform, omega divided by s square plus omega square. Cos omega t, taking Laplace transform of cos omega t is equal to s into s divided by s square plus omega square. So we can rewritten as 3.2.3. we get finally sin theta and cos theta are constant terms. So in that initial condition of operation of current I of 0 is equal to 0, we have put this equation 3.2.3. The new equation we get I of s is equal to Vm divided by L 1 divided by s plus r divided by L into omega cos theta divided by s square plus omega square plus s into sin theta divided by s square plus omega square. In this equation 3.2.4 can be rewritten as I of s is equal to a divided by s plus alpha into s square plus omega square plus b into s divided by s plus alpha into s square plus omega square, where a is nothing but ab alpha is a constant term. A is equal to Vm divided by L into omega cos theta. B is Vm divided by L sin theta. Alpha is equal to R by L. This is the constant terms. We have taking the inverse Laplace transform on that equation 3.2.5. We get I of t is equal to Vm divided by L into alpha square plus omega square into omega of cos theta e power minus alpha t minus cos omega t plus alpha by omega into sin omega t plus in sin theta of alpha cos omega t plus omega into sin omega t minus alpha e power minus alpha t. This is the basic equation of current I of t. So now equation 3.2.1, we get tan phi, and next one is sin phi and cos phi. Oh, this equation will substitute the equation 3.2.9. The tan phi is equal to omega L divided by R. That means already we know that alpha is equal to R by L. So we get tan phi is equal to omega divided by alpha, and next sin phi is equal to omega divided by square root of alpha square plus omega square The next cos phi is equal to alpha divided by square root of alpha square plus omega square. We have substitute this equation in equation 3.2.9 and simplifies. We get the new equation of I of t, and this is the equation of 3.2.10. This is the waveform of RL sine wave excitation equation. We have to compare steady state term and transient term. So finally we get resultant current I of t. In this waveform, current is taken as a y-axis and time will taken as x-axis. Okay, thank you.